Quickly, a background on DMC. We were founded in 1996 in Chicago, Illinois, and are an ignition and Seppasoft Premier integrator. We started doing ignition in 2016, and by this point have, I think, 100 plus ignition developers. So we can do small site deployments and quickly scale up to enterprise scale rollouts. We really do everything in the industrial automation landscape, PLCs, HMIs, MES, and robotics. That breadth lets us take a holistic view and make solutions that fit. So the question we're trying to answer today is how do we scale from a pilot facility to a production facility? And I'm going to be talking about a project we did with Sila Nanotechnologies. So Sila is a battery material manufacturing company that creates silicone-based anode materials to improve the energy density of lithium-ion batteries. They started in Alameda, California, and still run a pilot line there. But over the last few years, they've also been ramping up a full-scale production plant in Moses Lake, a city in eastern Washington. This means they've had to confront how to scale from around 8 PLCs and 50,000 tags to 25 plus PLCs and hundreds of thousands of tags. So first thing I want to talk about was just some common scaling problems from the integrator perspective and more on the program level before we get into the technical deep dive. So we identified 5 problems here. First one being just a lack of investment. If you go into a scale-up project with the mindset of doing the bare minimum to get running, that might work for a pilot plant, but it's going to be really painful later. Lack of internal resources is another key problem. Engineers are often already overtaxed and don't have time for big picture design if they're still supporting an existing line. As you get into these large scaled up projects, there's also larger scope and just more voices in the room. So you're working with EPCs, more OEMs, all sorts of different contractors, and that just adds complexity and misalignment risks. You also end up with limited vendor visibility. So you can have very strong internal development standards, but those can drop or break down immediately if an OEM drops in machine that doesn't use your standards. And then last, just geographic differences. So as you get a new plant, you're going to be looking at new time zones, different teams, and different sorts of local issues. Sila has done a really good job of mitigating some of these risks, and just want to talk about how. So the first way is they've got dedicated internal teams that are supporting the new plant work versus their existing pilot line. They also do a really good job of upfront expectation setting and pushing their hardware and software platforms down to OEMs, or at the very least getting their source code. And then last, they've supplemented with external resources where they need to. So going to be talking about 4 of the technical issues that we ran into on this project: control standardization, flexibility and uptime, key data access, and then the consistent user experience. So first question is, how do we standardize control streams between different tools, systems, and developers? Sila started with really a variety of tool vendors with different standards and different PLCs and different UDT structures among both the vendors and even the internal Sila teams. So the first thing they did was to create a set of standard smart UDTs that are used across all of their equipment. And Ignition's UDT flexibility and support was key to this approach. Next slide. The way that Sila structured the UDTs was, again, standard across all of their devices and had kind of a unique structure. So they started with some industry standards and then built out their own structure where each different type of device has the same set of 4 sub-UDTs: meta, command, event, and telemetry. Each of the UDTs serves a different purpose and has a different set of components per type of device. So each of these different UDTs allow different data logging and display strategies, and they allow easy structuring of historical data versus having all the information bundled up in a single standard UDT. And to enable the use of these UDTs, they developed a spreadsheet that was available internally as well as to all vendors. So this allowed really quick and easy import of UDTs from Sila developed PLC code. However, you can see in the columns on the right, it was also used as a way to allow vendors to map their own tags into the Sila standard UDTs such that their Ignition HMI could use the same objects for different sorts of PLC code. So folks were able to keep their own code structure, but serve the data up in the same way so that it could be displayed with the same Ignition components. The next question we were trying to answer was, how do we bring tools online quickly and provide flexibility for future downtime? Sila is a startup and R&D environment. So this means they need seamless tool onboarding, and they have really high data volumes as they log data and try to improve their process. Originally, they used a gateway network for everything, which led to really tight coupling of OPC data. This also required a lot of manual setup and didn't scale super well. They landed on a structure of using the gateway network for distributing project resources, and then MQTT and Cirrus Link modules for tag data. So tools publish once, and then consumers subscribe really to only what they need. This decouples all the different gateways in the system and makes them more flexible. The MQTT engine also automatically discovers tags, which really makes onboarding new tools easy. This is a nice hybrid model, so it's easy to use and leads to really fast and resilient tool onboarding. The next problem here is key data access. So how do we generate and provide key system data to key personnel? So here the goal is we want to provide data when and where people need it, be able to really log all parameters by default, and then simplify the backbone for this data collection. So previously tools were really just logging separately and had brittle one-off connections. This required people to make manual requests for data, and there were inconsistent formats across OEMs and teams and PLCs. It was just hard to trust the data. Sila developed a unified namespace approach, so a single centralized model enabled by MQTT and standardized tags. This meant one namespace with many consumers and democratized access to this data across all the systems to get it to the right people at the right time. You can go to the next slide. So here's kind of a diagram of what that looks like in practice. All the devices publish once via MQTT to a HiveMQ broker. That broker then allows access to the standardized data all in one place. And the UDT structure that they developed makes that data easily understandable. All the various consumers, whether it be historian, perspective, seek, an internal MES application, all subscribe to that single location and can easily get the data. And then the last challenge is creating a consistent user experience and making sure that there's a single look and feel from the edge through to the central control room. To start the project, they really had disparate OEM and internal team HMIs, and there wasn't standardization on how to display data. This inconsistent approach between teams and developers meant that operators faced a patchwork of interfaces. The solution here was to create deployment pipelines via the gateway network and then develop screens that use session properties and tag parameterization such that the exact same screen could be used on multiple different gateways and display data correctly. So this is an example of some of the HMI devices that ended up on the screens and were developed. The UDTs were really the basis for the objects, and they each have multiple different representations that can be used at different locations, even though they share the same tag UDT. So an analog display might have a very small numeric indicator in some places and a larger one with more information in others. This allows for displaying data in different ways depending on the specific required context. The pop-ups that came from these device UDTs are shown here. And so we talked about how the data is really divided up into the same 4 UDTs throughout the project on the tag side. And those UDTs were used to organize the data on the device pop-ups as well. This makes it really easy to find the data you're looking for, no matter what device pop-up you're looking at. And it also makes it easy to just enable access control per property. And the standard user interface really based on that standard data UDT structure makes sure that operators and engineers are able to quickly digest and use these HMIs. And then finally, just wanted to discuss how screens are deployed. Again, the key thing here is that the edge and central gateways are using exactly the same screens. Those screens are using session properties and different tag bindings to handle differences in the tag providers between the edge and the central gateway. And the screens are pushed from the central gateway to the edge with the enterprise administration module. This architecture and strategy just really allows for efficient development since you really only need to do it in one place. And again, achieves the goal of a consistent user interface from the edge to the control room. So thanks. Back to you, Reese.
Excellent. Yeah, appreciate you going through that, John. Very, very well described project there. A lot going on. I appreciate at scale, it's also important, I feel like, for end users to have a similar experience. So I appreciate you kind of going through the visual side of things and how you manage that and those types of things. One of the questions that I see, I think it's specific to your architecture. And I want to say that it was referencing, I'm going to flip back to a couple here. I think that it was referencing this architecture. This person asked, I missed what Ignition Edge was doing in architecture. Is Edge accomplishing something a full Ignition instance could not do?
think the answer is no, but the edge here is just serving as the actual connection to the PLCs and then a local HMI display as needed. So there wasn't necessarily a need for a full gateway in that location.
Yep. And I think I'll add a little bit to that too. A lot of times edge is used in places where if connectivity, say, to that MQTT server, that broker in the middle does go down, you still have local operations as well. And another thing that it does a lot of times is provide a store and forward buffer as well as secure data transmission up to that broker. So if you do need to get it into MQTT protocol, Ignition Edge can talk those lower level protocols, Allen Bradley, Siemens, Modbus, etc., transfer it or transform it into MQTT and publish it up to that broker. So some other reasons why you might use Edge there as well.